kind of give you a tour of what various things have changed in it, and hopefully it'll make it all make sense. And then you'll understand network programming, and then everything will be easy from there on out. Yeah, let's take a look at it. See this for the examples. All right. So the chat server had very many bugs in it, most of which have worked now. I'll show you it just kind of like working a little bit. So I'll go ahead and put the chat server up here. And automatically this is on port 5141. And then down here, I'll go ahead and mount the software examples directory. Like that. And we'll open up the client. The G-Chat client, or so I think they call it chat client in the build file there. We connect to our software to LCSC.edu, port 5141. All right, so you can see that the chat server has accepted a connection from our computer here, 192.168.18.25. All right, I think I'm going to further restrict the real estate down here and add another side to it, and I'll go ahead and connect to a computer that's not at that address, although Canary it's been really slow there for some reason lately. I don't know why. What's up with cable one? I'll use Nimrod. All right. I actually have all of my software mounted on Nimrod, but for various reasons that aren't going to make a lot of sense unless I spend a while talking about them, my web directory is in a different spot when it's network mounted in the way that it's network mounted there. All right. Okay, the prompt now wraps over. So I can say chat client, software.lcsc.edu, and 5141. All right. Oh, I forgot something really important. I didn't specify dash capital Y when I, oh, it's not going to work anyway. All right, fine, run on the software remotely, graphically. So that one will run on localhost. All right, so now we got two open. Oh, we had a bad problem. Well, that didn't happen when I was testing it before. I'll try sending a message here. Send message. Hey, look at it. Weirdly enough, the message worked on both sides here. Oh, I know what happened with client_u. When I started it on Nimrod, which is probably the one at 74.118.22.223, like the campus wired network gateway, not the wireless gateway, the wired one. Since the GUI failed to start, something probably happened that was unexpected. All right, so that's fine. So the two Glorfindels are fine. We've got one at 127.0.0.1, and we've got one at the 192.168.1. And so they can write back and forth. Now, one of the things we're going to have to add is some ability to go ahead and change your name. But you can send messages back and forth. Now, notice it also didn't continue making a log. All right, that's something else. So anyway. Yeah, so you can send the stuff back and forth. It works. It just doesn't log it. The server up here does log it. The server will say what messages it got, and it actually needs to have the debug output trimmed down a little bit. Plus, some of the debug output is actually a little bit wrong. All right. So let me show you how it works and what I did since last time. Not a huge number of changes. Mostly just a whole lot of little minor ones. The plan was fine last time. All right. First of all, billing. So I went ahead and made a makefile for it to take care of the PKG config stuff. It was a little bit what a hassle to add. So now we've got, I got on the command line every time we ran it. So now you just type make and whether you want to make the client or the server, and it builds it. Cool. It does have one minor disadvantage on here. You can't, well, no, you can. If you build the server on a machine that doesn't have GTK plus development libraries on it, it will send out a warning the PKG config can't find what it's looking for on standard error. But it will actually work. It builds fine on a machine that doesn't have GTK for the server. GCC, I believe it is smart enough to know that if it's given a whole bunch of libraries to link to and there's nothing actually used from them, it'll just kind of ignore them for you. Certainly with the include ones, it gives it extra paths to search, but if it doesn't actually have to search any of those because it found all its include files, then it doesn't really cause an actual problem. So even though the server is built using these C flags and LD flags that are appropriate more for the client, it works okay. Oh, there's an error in the make clean too. You can see where I stole this file from. It apparently wasn't here. All right, asterisk.o, that removes all the objects that have been built. And that will remove the 2 binaries. So that cleans out the directory if you need to rebuild. Usually the reason you need to rebuild is that your make file has something wrong with it. For example, perhaps it doesn't have the header file set up as something that each of these 2 targets depend upon. I just noticed that looking at this. So then if you change your header file, it doesn't actually go and rebuild the objects, which could be an actual problem. So then if you make clean and then rebuild, it usually works. So your make file is perfect. You really shouldn't ever have to do make clean. But sometimes you just do. All right. If your clock is set wrong, you can also do make clean. Because it might look like your binaries are plenty new enough when they're not. All right. Yeah, anyway, it has made clean now. All right. So then the chatlim.c. All right. Not much of anything changed in here. Mostly I just fixed little bugs. Bugs that aren't very interesting. For example, this up here said ampersand buffer, and that would indicate the address of buffer as in a char double star. That's not what we wanted. We just wanted the actual buffer here, and so it shouldn't have an ampersand. Anyway, little stuff like that kept it from working for a while. This is debugging stuff that should go away. There were some arithmetic error. I had a 34 instead of a 35 on this. Yeah, that kind of stuff. All right, so no major changes in here. It uses the same general plan as it did before. I don't think send message actually did have any changes in it. The server. All right, so the server, I think last time, I don't remember how the data structure set up last time or not for this. I don't think we really talked about the final version of it much at all. So I have these struct CL infos, and a CL info includes all the info for a particular client. In this case, it's just got the IP address, the socket, and the name. One reason for this, as opposed to 3 parallel arrays, which would be another way to do it, just like an array of IP addresses, an array of sockets, and an array of names. The parallel array starts to get a little bit messy after a while, and especially if you're trying to add something to it, because then you have to manage all of the arrays separately. So we decided that for each one, we also wanted to have a message count, so that we can let people level up. And if you're leveled up, for example, if you get to level 5, maybe you're allowed to use capital letters. We won't let new people do that because they might abuse the privilege. You could do something like that. That could work. All you have to do is add it right here, and then it becomes part of this structure. And all the rest of the memory management stuff will accommodate it just fine. So it makes it easier to add things like that, having a structure for this. Finally, it makes everything feel more natural to everybody that's had object-oriented programming, because now it's not kind of an object, a kind of object. All right, it's got data, just no methods. All right, so then the management of that one happens down when we connect. So this stuff's mostly from simple client up there until we get to the client list. And the client list is a list of pointers to clients. So we end up calling malloc when every client connects. We were talking about trade-offs last time, and how we have to start a thread for each client anyway. So it's, something. It's kind of like when you buy a house. The house is expensive, and so there's a special ceremony when you buy the house for closing. And at the ceremony, the rule is that anybody is allowed to come up and introduce themselves as anybody they want and demand any amount of money from you that they choose. And everybody just does it. So they come up and they say, I'm the arbiter of property lines, and so I need $550, and then you hand it to them. Because you're spending so much money, what does it matter anyway at that point? All right. So and for anybody that hasn't bought a house, I'm actually joking. There's quite a few rules. Well, people that'll be like, the title company or whoever.
Feels a little bit like that, but they're not actually allowed to make it up. So don't try it. All right, so the client list here, we start out with 1,024 of them and keep track of how much memory we've got available. So then if we've got a list that's equivalent to the amount of memory that we have, or if it somehow got bigger, I don't think it can, then I always just do these things in kind of a paranoid sense. It's like, well, you know, we should do that. It's like timers that have reminder beeps. That way you can't miss it if you just stepped out for a minute. All right, so the client list size, if that gets too big, we'll go ahead and tell reallocate the memory larger. And so then we go ahead and increase our amount of memory that we have available. So each time we get a new client, we have to make a new structure for it. And it's again put on the heap here dynamically. And so we just fill it out with the details that we happen to know. That would be the client file descriptor and the, I feel like these ought to be grouped now and that should be reversed. And the IP address, and then we go ahead and add it onto the client list, increasing the client list size. Okay, so that's about all it really takes to make this expandable structure. Now, that does leave us with the problem, what do we do when somebody leaves? Because if we keep adding to the list and never removing anything from the list will continue to grow bigger and bigger and bigger and bigger. And then eventually our server will have a problem. I'm sure you've seen a program on a computer where it uses more and more and more memory, and then you close it down and open it up doing exactly the same thing, and all of a sudden it uses a fraction of the memory it did previously. But we don't want to make that kind of program. All right. If somebody leaves, we first of all find out which position we were. I don't actually have the CL positioned in the data structure anymore. We could store them. They're not stored right now. And so we just take this little loop here and run CL pause down to the position of our client. And then we go ahead and swap our client here with the one at the end of the list. That should be a minus client list size though, because client list size is going to be one past the end, which is going to eventually lead to a memory error if people start leaving. All right, I just found a bug. Amazing how going through and explaining your code reveals bugs. Because you start explaining something and you're like, this is how it, yeah. All right, so this should be the last position in the list, and we copy that one to our current position, and so that way we've decreased the length of the list, and we haven't left a hole in the list. This does mean that the order changes as we go, which is part of the reason I took the CL position out of the data structure, because if it's going to start shifting on us, it can't be stored that way. All right, let me go ahead and free our memory that was associated with that one since we allocated it on the heap, and then we go ahead and return from this function, which should close down that thread. All right, so that's that one. The relaying here. So I went ahead and left the server relaying back to the person who sent the message, as well as everybody else. Last time we had that blocked out so it wouldn't happen. Most of the reason I left it was because my client doesn't actually add the message to the chat log unless it receives it. So it's an expedient way to make sure it displays what you said as well. It also made it easier to test things because I only had to open one chat client for a debug cycle. Because then when I send a message, it should come back to myself, and if it doesn't, then it doesn't work right. All right, anyway, could serve as a keep alive, I suppose, not strictly required. All right, the what if it's too long actually was a historical thing. We decided to change the buffer size to make it so it's not too long. So I guess I can take that out. Okay, so then the interaction with clients. So this part still needs to be dealt with in the client. I think the server probably doesn't need any modification today. The client does. All right, so I've got this infinite loop here. This is the making up a username loop. Now, I haven't actually started this one working in the actually make up a unique username sense. So we go ahead and read a message, and if that doesn't work, we got a bad problem. Then we go ahead and check and see if it's a user message. That's how they're supposed to start things, by just saying what their username is. So if the user hasn't said that, then they're not following the protocol. We're calling that a bad problem, and one could switch to this and just call it like a medium problem instead, or like around the loop we go again. You could do something like that. This one doesn't. All right, then we look to see if the username is taken. Right now, find username just returns 0, always. I said that because the client currently has the username hard-coded in, and so it's not actually possible to change it in the client. Right now it ignores duplicates. All right, and then if the name is taken, it'll go ahead and write a name taken, except that that branch has never been run. All right, so then we should announce that this client has just arrived. And so this runs through the whole client list and sends out this new user, and you can see that there. Plus, for the person who's connected to the server, they get their username back and they can see that it worked and they're actually logged in now. Then after that, we start handling the interaction and relaying messages. All right, so not a lot special going on there. Same thing with the GChat client. Minor bugs have been fixed and nothing major. So, right now, the username is Glorfindel, and you can't change that. So, for example, if somebody had only watched the movies and not read the books, they could not have a character that they recognized. Okay, so take a look at the client real quick, the way it comes up. So when we start the chat client here, it might be awful nice if it had something like, you go ahead and enter your username first, and the first time you do it, that's your username. And we can even print out stuff about that down here if we want to. So it starts out with write your chat message here, which if we want to do. All right, I'll forward it. I think we're in a receive loop from the server, but there isn't any server going right now. So we ended up stuck in an infold open with that. That should probably be fixed too. All right, anyway. All right, currently when we send, it's we use this one right here. Oh, I had to rename this too. It's called send message before, which is the same thing as one of the functions from the chat lib. So anyway, all right, so we go ahead and send our thing the first time. I'm gonna go ahead and, well, we don't necessarily need to say we're doing that. I guess it's fine, we can leave it for now. All right, the first, if we have a username, then for setting our username, we should probably send out our username here or something like that. Instead of down at the end of activate currently, we're sending our username right here. All right, so that sends usernames. Okay, might be a good idea to put that in some kind of function. I'll just go ahead and so down here with our SM callback, when you click on the send message. So we currently are doing this stuff. If we go ahead and say instead, if we haven't got a username, okay. We'll have to set the username like that, so that happens. Then we'll go ahead and send this as our username, and else we can go ahead and send our message the normal way. All right, so we do something like that. That'll take care of it, except that the username actually needs to be set. It looks like we've already got our text as the text right there. So we should be able to just put that in the username. All right. 32. 32 bytes is how much we have for a username, so that'd be the maximum. All right, so come down here. The username is, we need to make that happen. That should go ahead and send a username. All right, we already took it out from down there. So then the initial setting here, if we set this to just be an empty string, the strings will be null terminated. So we should end up with a null terminator in the first byte of username. So username should start with a 0. So our if username at position 0 is 0 should be true the first time, but not after we've set our username. All right, it still doesn't deal with an unacceptable username. But let's see if we can change usernames here. All right, build our client. My software. That'll be fine. As long as I can pick the one that exports. Hey, I did. Cool. All right. So this might be kind of unhelpful since this is actually
requesting a username. So we had some kind of username. Let's use mine again. All right. So got message. That actually probably is not what we should have had. You can see the username is actually not set there at all. And we still ran into that infinite loop. All right. So it kind of looks like it sent it as a message, and then it did not go down here and, oh, probably because I said equals 0 instead of double equals 0. All right, so I'm starting to like the debugging. Oh, we got a problem. All right, you notice how it didn't say anything down here, new client or whatever. So I Control-C the server, and we haven't had the server go shut down gracefully yet. So maybe we should be adding a couple of things to the server. If the server actually calls close on the socket, then the socket will be free right away, which would be kind of cool. All right. Yeah, totally not working. The server also should be able to operate on more than one socket. All right. So. Handling Control-C gracefully. So we're in this main loop here, and you can see there is no break out of this loop anywhere. We just are stuck in the loop. And so our expected way to kill the server is just like Control-C it. So if we Control-C it, we'd expect to actually close the socket, which this line will never run right here. So we want to handle that signal. So if you had CS-430 already, this is kind of old hat. We're going to make a function. It's what we want to do if we're closing. And I think it returns void. Call it shutdown. There might be a function called shutdown. Oh well. All right, it takes an int. That'll be our signal number. Say signal. All right. So when we close, we're going to close our socket. All right. But this socket right now is right there. So we want to make that socket something that's global. It's global to this file. Remember in C you've got local variables that are local to a function. You've got ones that are global to a whole program that you define in a header file and use extern for. And then you've got kind of the intermediate level, the ones that are global to a file. We're talking about a global like to this file here. All right. So close that and exit. All right. I think exit might be in sys. Takes the exit status. That's the parameter there. All right. So that should get us out of the program. So then we need to set up that signal. Probably the right spot to set up that signal is after we've made the socket, because until we've made the socket, there's no need to close it. If you Control-C it right here somehow before we got to this line, it wouldn't actually be a problem. All right. So setting up signals, we're looking for this function right here. It's in signal.h, and it sets an action for a particular signal number. And this is a struct sig action here. At least a sig action structure is defined as something like this thing down here. All right, it's the SA handler we're interested in there. You might see the parameters there actually match the thing we just wrote. And so that's what we want. We're going to struct sig action. All right, sig action. All right. That's what I call it. All right, and sig action. All right, so now the next thing is our signal. All right, here's so I typed in man 7 signal. This is the overview of signals man page. And so I believe a sig int is a Control-C. Now we might want to handle more than just a sig int. There's also a few others, like for example, if we got a sig segv, an invalid memory reference, normally this kills your program, terminates it. For a server, especially one that you're debugging, it might have memory errors in it. It might actually be nice if it closed the socket before it shut down with an invalid memory reference. So you can handle a few of these. Sig term if somebody kills it. That's a pretty good one too. All right. Element, do that. All right. Sig term was there. Sig int is the one that I'm really interested in. All right, last parameter on there. All it does is if you had a previous handler on there and you wanted to deal with it, you can just have that right. You can receive what used to handle the signal there. If you want to switch back and forth. All right. Now, one other thing about this segv. So you don't want it to shut down. You want it to shut down gracefully, but it. We'll go ahead and say if signum was segv. Like if it was a segmentation violation, we might want to print something out and, you know, let the user know. All right. All right. It's not exactly the default message. We can go get the default message if we wanted to, but this will be okay. All right. Okay. So let's see. Oh no. Hey, sir. Oh, we probably need to include signal lot H. All right. I knew we needed it, but we're getting kind of a laundry list of includes, and a lot of times once you get a laundry list of includes, most of the things that you need are actually already included by something else. I was kind of thinking there might be another function named that. All right. That's the section 8.1. And shut down. Shut down part of a full duplex connection. So, now you know. Hey, it's even a networks related function. All right. Struct sig action. It's called SA handler, isn't it? All right. All right, so now the server should shut down gracefully. All right, next time we need it to. Okay, what are we testing? Oh yeah, usernames. All right, so that was where the chat client was. All right, so we got a connection from localhost. So if we want to include a username here, username. All right. Hey, there we go. Sure. So then we should be able to say something. Hi. So what people say in chat rooms? I don't know what they say in chat rooms. All right. So it continues to work. And so the logging doesn't log things. It just sort of gets rid of everything every time. Oh, hey, let's Control C it. Let's start it again. Hey, look at that. Works right away. Cool. All right. Yes, logging thing. Okay. All right. So this part we get to learn about the GTK side of things a little more, and less the following network protocols side of the world. The additions are happening right up here. All right. General principle on most widgets on toolkits is that they're backed by some kind of buffer, which will have different rules regarding to whether you want to append or replace the text. In this particular case, we're GTK buffer set texting, and we're setting it to the chat log buffer, which we have right up here. And so we're actually setting the buffer's text to next message, whatever that happened to be. All right, let me go pull up the documentation for that function real quick here. All right, I don't even have a web browser open here. Probably not. All right, probably means I haven't actually clicked on it. Oh no, I had to click on message. All right. Okay. Now, web browser is very forgiving about making mistakes, but all right. So, here is how it works. Well, somewhere in there. That one. All right. So we give it a buffer there, like a pointer to it. Deletes current contents of buffer, which we didn't actually particularly want to do, and inserts text, that is the text right there, instead. If len is -1, text must be null terminated. Text must be valid UTF-8, that's ASCII. All right, so we got the text, but we didn't really use it for anything. We just went ahead and set text to it. All right, so here's our list of stuff we can do with text buffers. Since we're kind of looking at this in a C form, we're not looking at GTK MM, we're looking at regular GTK here. It's kind of a set of things that work on it as opposed to a set of methods. But they do kind of the same thing here. So we've got a number of insert options here. If we take a look at GTK text buffer insert, inserts len bytes of text at position iter. Iter is a GTK text iter. All right, cool. It's a position in the buffer. If len is -1, text must be null terminated. Sure. It emits the insert text signal. So if we wanted to, we could have another callback run whenever text is inserted into our text box using this function. Not something we really want to do right now, but it's available. Iter is invalidated when insertion occurs because the buffer contents change, but the default signal handler revalidates it to a point to the end of the inserted text. Hey, isn't that interesting now? So if it revalidates it, like, it comes back at the end of the inserted text, that means that it's actually going to stay on the end of the buffer, which could be rather convenient. Because if we want to keep adding text onto the end of the buffer, then having a pointer to the end of the buffer to say where we want to insert it at could help a fair bit here. All right, there's a whole insert family here. For example, we could use the current cursor position as the place to insert it. There's interactive version, interactive at cursor, enter it at a certain range using a few GTK text iters. All right, insert with tags. All right, but you get the point. There's lots of different ways that you can insert things, depending on what you might want to do. All right, GTK text iter we have to deal with. All right, this is a text buffer iterator. And so we can GTK text iter get buffer if we want to. We can free one. We can, there's a lot of things actually. Ends line and start sentence and, oh man, that really goes on a long ways. All right, so the iterators on here, you see it's a memory pointer, and so it's actually got some kind of object behind it. And yes, as you may wish to begin by reading the text widget conceptual overview. Yeah, you really might actually want to. It's kind of lengthy. It's not that lengthy. It's not that bad. All right, they have an iter in it. Most text manipulation is accomplished with iterators, yes. And so that shows you where things are inside these buffers. All right, actually here's a kind of an example. So we got a couple of GTK text iters. We got a start and an end. And so then, there we go, start. There we go, highlight them. You can see we can get iter at some particular offset into this buffer. So this allows us to get a text iterator that applies to a particular text buffer. And so there's an iterator that refers to character 7, I believe, on that particular text buffer, which would bring us back to the text buffer documentation over here, where you can initialize iter to a position char offset characters from the start of the entire buffer. All right, if char offset is -1 or greater than the number of characters in the buffer, iter is initialized to the end iterator. All right, tired of iterators yet? All right, let's go make this thing work. All right, we are going to need to have an iterator, and it's probably just something that's going to be related to this function up here. And so under here, it's going to be a lot like over in in this demo here, where we've got these GTK text iters. that indicate the, this will stay on the end of the buffer. In fact, I kind of like their name. All right, that points at the end. Well, we made the point at the end anyway. And so we have to start it out pointing at the end. And so one way to do that is with this GTK, you know, I forgot to capitalize G when I made the text editor. GTK text buffer get iter at offset. All right, let me fix this little capitalization issue there. Is it capitalized again? Nope. All right, parameters on this thing, we need our buffer, and so that's our entry buffer, and then we need the address of our iterator, and then 0 would just be the beginning. There's nothing in there at the moment, and so the end and the beginning are the same thing. It's an, well, I think it might have like an initial message in it, but we want to overwrite that anyway. All right, so then down here, when we add stuff to it, instead of GTK text buffer set text, we're going to want that other one we were looking at over here before the text iter, and that's the insert range one, or not insert range, excuse me. I was looking at insert range and thinking it was wrong, and I said insert range. All right, GTK text buffer insert, where we have our buffer and iterator and text, and all right, text buffer insert. All right, we're going to put it into that buffer. No, I did the wrong one up here. Nobody corrected me. I wonder if that means that nobody cares about iterators. All right, next message, and just until the end there. All right. So, I don't have a huge, like a lot of confidence this is going to work, but we can see if it does. With implicit function defined, get iter. There must be a typo in here. Text buffer get. I said text iter get iter. Yeah, all right. I said it wrong. All right. Use cut and paste. Okay. There's our thing here. I'm concerned that I might be coming down with a cough because my 3-year-old had a cough, and I occasionally cough. All right, so we get a new client, and we can go ahead and start our chat server. And it's actually going to start it on a local machine, but it's fine. And so we first want our name. Whatever, send message. All right, we got that name. Now we can say something. Hey, there it goes. All right, incidentally, the whole chat log thing didn't go away. We could just get rid of the initial text, but let's send another message. All right, for the Y. Hey, that's continuing to work. All right, we've got a chat log. That actually logs. All right, so we can quit if we want to. Oh, quitting causes a bad problem currently. It might be nice to quit instead. It's more like, you know, user such and such has left. But currently, the client doesn't send out anything to say that we're leaving. It just terminates the connection abruptly, which the server interprets as a bad problem and dumps that particular client. Incidentally, this is often a good test of a server. What happens if we just go ahead and like start another one and go ahead and see? All right, should probably have that to like send name or something first and change the text there. Oh, and I don't have enter as a send on that one either. That would be kind of cool. All right, well, anyway, it seems to continue to function and not crash. So that's good, because we should have recycled the same spot in our list. And sometimes things like that create memory errors if you didn't run. All right, so that is somewhat closer. All right, and you know, the server's better in that regard too. All right, so the kind of GUI design part, putting things together, and you can kind of see how one works with one of these GUI things. It really depends on which one you're at. Once you get used to a GUI system, it does get faster, and so if you're going to learn one, it's kind of good to learn one well enough that it's easy to use for you. I haven't used GTK quite enough for it to be something I use quite naturally.
I should probably pick one of these days, but I hardly ever make GUIs. Anyway, so I haven't wrote Lab 4 yet, but I think Lab 4 is going to be adding a feature to it, probably private messages, unless somebody else has something that sounds more interesting than that. And the options to start it, option 1 is just go ahead and modify this thing here that kind of mostly works. And option 2 is pick a user interface toolkit you actually like and a programming language you actually like, and just kind of restart the client. There's not that many lines in it. I suspect that if you start with a language that you like that includes memory management and things, you may end up done just as fast starting it from scratch. So you just have to look for the same kind of language features. For example, I think if you did this in Python and Kinter, it probably wouldn't take you very long to redo all this. I don't know if I've ever showed you the simple server in Python. I almost hate these days because you can do this simple server like I've been doing in just a handful of lines. Same thing with the simple client, just like 3 lines or something, and you can have it. But it makes people think that Python is a little bit too easy to work with. And the usual place people run into trouble with is stuff like if you have an unsigned 2-byte integer. Python is very easy to work with ASCII text, but you start needing to find some kind of library to parse things out if you got integers of different Indiannesses, or we just did a little Indian with this without thinking. That violates the protocol. Probably easier to change the protocol. Anyway, when you start working with stuff like that in Python, it kind of is a little bit more difficult than the way things work in C, where C really just exposes what the data is and lets you deal with it. People have been kind of, usually with this class, we see maybe 40% C, 40% Python, and 20% something else. And I've never particularly noticed that the Python folks or the C folks get better grades on a project. I definitely help the Python folks and the C folks with different types of bugs. And then the something elsers usually are more or less fine, because usually when somebody is like, oh yeah, I really want to do this project in Java, because I like Java and I want more practice with Java, and all the job listings I'm interested in say they want Java, I'm going to do Java. Usually they're motivated enough that they don't have a lot of trouble. C# has been big in job postings occasionally. Top programming languages. C was actually the fastest growing, believe it or not. Like ancient language. Anyway, there's various rankings for these things. So if you look through the article, you see which ones are top 10. Now, depending on which listing you look at, you'll see different orders. The methodology, it changes, and it's like, do they look at job postings? Do they look at senior positions? Do they look at entry only? It depends. But they include web. If you include web, it really changes the mix of languages a lot.
One of the other things that these particularly take upon is how often they're searched. So there can be more of how many problems they're having trying to do these, rather than it being popular.
Yeah, that happens too, yes. Yeah. All right, anyway, lots of metrics here. We try to keep the languages in our program basically ones that will appear somewhere in the top 10 by some measure or other, just to try to make sure everybody's skills are at least somewhat useful. This is in contrast to when I was at Western Washington University, and we taught 8 and 95 for the first year of programming, which, it's fine in a sense. You need to learn the general principles of languages so you can pick up new ones. If next year suddenly Rust makes a major uptick and all of a sudden all the job listings are in Rust, I'm hoping that you all can pick it up. It caused problems for our students when they go to a job interview, and the interviewer would be like, oh yeah, what's your strongest language? And they'd be like, 8 of 95. All right. Yeah, Python, Java, C, C++, a lot of these are up here at the top. C# is usually in the top 10 somewhere. Swift is up and coming. Objective-C always used to be in here, but it's dropped down the bottom these days. Go is, I'm surprised to see it.
It's a lot lower on the Toby index.
Yeah. Anyway, so if you're looking for one to do, can you do this whole thing in R? I don't know.
Pick up arc, no way would I try to do this.
Well, yeah, it might be possible.
It's possible, it's not, it would not be fun.
I'm fairly certain you can do it in that lab.
Yes, if you can afford a license.
All right, anyway, okay, so that's probably about what Lab 4 will be like. Either way, and you don't have to, whatever you do in the Lab 4, and you don't have to stick with that for the alert server. In fact, with the alert server, if you use something for the client, and at the end you're like, man, that was awful, you can change your mind for the server, it's fine. You don't have to do them the same. I structured this one with this live chat, or chat lib. All right. So the chat lib in this case didn't end up that big, but it did take care of some parsing. Having a common library for the client and server does save a fair bit of code. I think my lurk library is 200 or 300 lines. The lurk cat and the lurk server and everything I'll share. It definitely can be useful, but not actually required by any means. And the other thing is, if you're doing the network library for the first time on the client, you might at the end be like, well, I was going to use this with a server, but actually I want to bury it in a deep hole and never see it again. So sometimes that happens too. A lot of times people in this class kind of are redoing things. I haven't done a redo on my client and server for this thing in the 4 or so years. But in a lot of ways, I almost wish I had, because Lurk changed so much from protocol version 1 to 2 that my server is full of stuff it does, like needless conversions and whatnot, that I kind of wish I had just thrown it away and redone it on Lurk version 2. Anyway, and I actually did throw away and redo my connection library when I switched to Lurk version 2. All right, so that's considerations for that. I think as long as they client server makes some sort of sense, I think we're mostly there on that. Oh yeah, user interface stuff for the project. I'm not sure I posted the project description. I doubt anybody was going to start writing it yet anyway, but if you were and I thwarted you, I'm sorry about that. Let me see. Oh no, it's not there yet. All right, so I'm going to talk about that project just I want to talk about Lab 3 just a little bit, and then that one. All right, if you already finished this, cool. But a couple of practical notes on doing this and dealing with the lurk stuff. So lurkcat LC localhost 5190. All right, there's a few regrets I've had or feature things I'd like to add on this LC, and I might get to them at some point. The main problem with LC is everything scrolls off through the top of it too quickly. And so in some cases, like somebody has gone and filled a room up with 100 bots and then let them all die and then left. That really is kind of unavoidable. I thought about making a compact format for these things before. That would, instead of say with a version up there, let's use it 4 lines, type 14, major, minor, extension size, and there's a space. We could change that to just like type 14 and then either just put the actual words in a row or say, like version 2.2, no extensions or something, like a short format. So I've been thinking about doing that. I'm hoping to get to it this week. The other thing I might do on lurkcat, which would ease this a little bit, is have it go ahead and make a file where it includes a log. It's like a log file. And then if you entered a room with 100 bots and it scrolled off to the moon, you can then take your file there and even pipe it through grep or whatnot and try to find out whatever you needed to find out from it.
There's at least a few people in the room that you need to go into, so to make my font like 6 point, be able to see what's actually happening.
Yeah, yeah.
And sometimes it's hard to fight in your guts. Like I tried this, and like sometimes you would fight, and sometimes you would just send 3 million times, and then it wouldn't work, and then it would just crash and kick you out.
Oh, really?
So I had to use Lurkwolf.
Yeah. Lurkwolf is much easier to use because Lurkwolf is an example of an actual client as opposed to something that just shows you the protocol. I haven't looked at the server lately. The other thing that's on my list to do soon on the server is put some kind of cleanup routine in, so it rejuvenates the monsters and clears out all the bodies and whatnot overnight. Maybe twice a day or something. Maybe rejuvenates the monsters once an hour and cleans out the bodies every night. I don't know, some kind of management thread like that. I thought about just having it do a complete reset every night
But in some ways I don't necessarily like that, because if you left cleanly, you might want to actually reprise your character later for one reason or another. Maybe you don't, I don't know. All right. I usually start a lurk server on 5191 with a different map, and then there's the Hall of Fame ones. I think Alex actually has his running somewhere. 5,000 to 5,200. All right, Jesse's client is running on one of these. I forgot to say -P. All right, if I haven't talked about Nmap in this class, I feel like I have, but if I haven't, you forgot, or if I haven't. Nmap scans ports on computers. All you just try is connecting each port in the range. And so if you want to see which ports on a software are open between port 5,000 and 5,200, you run that command right there. And so here's the answer. And I think 5199 is Jesse's client. All right, so if I say LC, I know what maybe 5164, I don't recognize the thing on that. Hey, there we go. 5164 has a server running. This is Alex Romero's masterpiece. It has a much larger map than my map, or the alternate one I've put on there. He's put more effort into the literary merit of his server than I did. So it's actually kind of an interesting one to go connect on, and you can test your client on it and whatnot. Same caveat as my server, it's not guaranteed to be absolutely stable and correct in every regard. And it's probably alert 2.0, so I don't think it'll tell you if you're standing in a room with somebody and they leave. But just a minor caveat. I mean, I shouldn't crash your client or anything. It also won't send you a version packet, but again, it probably won't crash your client or anything if it doesn't. All right, so that's available to play with. I don't know what's on 5120. Right? All right, well, it's open for some reason. I think 5171 is our Lab 2 server. All right, yeah, anyway, there's Nmap. Using Nmap, so if you wanted to just port scan something for common ports, let's say we're just here and we're like, oh, let's open on Isopera. Isopera.lcc.edu. All right, there we go, we port scanned it. So here's a list of ports that are open. Now, notice I missed a few, like 5164, Alex server, that's not on here. All right, so what Nmap does is it scans the common ports that are used for services that are commonly used. So for example, port 21 there, it says is open, and port 21 is normally used by the service FTP. That doesn't mean that port 21 is running FTP. So for example, 5190 down there at the bottom is not running AOL, it's running a lurk server. All Nmap is doing here is guessing based on what that port number is commonly used for. And it's right about MySQL and HTTP and SSH. And I should probably write about RPC bind, although I don't know why I'm running that. I might stop. Now, if you really wanted to know what's on these ports, you can start looking at it. Nmap, software.lcc.edu, port 21. We're going to get an FTP server thing? Oh, sorry, I meant NC. No. We're talking to an SSH server. All right. The SSH server on Isopera, for reasons that were bad enough that I've completely forgotten, actually runs the SSH server on port 21 and 22. Actually, it's coming back to me now that I think about it. There's some network issue going on with port 22 and something or other I had set up. I think when I was testing Isopera and planning to deploy it, maybe when it was living on a cart in the server room there. And so I decided to run SSH on port 21 for some reason. And then, since I had that configured, I added it on port 22 later, but I didn't take it off port 21 because at that moment it was in the Sam Glenn Center, and I was feeling like a chicken because if I turned it off on a port where it's working, then I could potentially lose access to it. And since then, I don't know. I approached the SSH side of things a little bit nervously. It's like when you take the airbag out of your car, you don't put your face in front of it when you're disconnecting it. Is it the yellow wire? Is it the red wire? They're not that bad. I mean, it's not going to blow up. If you really care about it, disconnect the battery and it doesn't have any power to blow up on you. Yeah, everybody take out your airbag and put it back as a conquering your fear exercise. All right. I totally shouldn't advise that. Okay. So if you wanted to actually port scan all the ports, say 1 to 60,000. All right. Did I do something wrong? Oh, it said the net cap. All right, you gotta get your network utility straight. So it takes a little bit longer to scan. Since we were on a local network, it did not take all that long. The 4228 is probably an outgoing connection. Yeah, there's a complete list for you. All right, port scanners have a particular pattern since they go through and connect to one port, then the next, and the next, and the next, and the next. So if you think about it, if you're on the operating system side, and you're like, hey, I'm going to go ahead and put in a port scan detector. Well, since they got such a predictable pattern, they're rather easy to detect. You can totally do that. In fact, there's a friend of mine that was like kind of paranoid. He was really into computer security, and he wore a hat that was actually kind of a dark color. He also tended to wear like a long trench coat, which was unusual in Western Washington where it wasn't that cold out. I used to go walk around buildings with him, which is pretty fun. I used to go out in buildings too. But there was once when I was exploring a building in the night, and I actually locked myself on a balcony and had to climb down the outside of the building. Well, that never happened to him because when he went exploring buildings in the dark at night on campus, he carried lockpicks. All right. Anyway, so if you port scanned his machine, he actually would find out like immediately. So if he was sitting in lab, you know, he'd just be like, I'm gonna go port scan his machine. And he'd do it, and he'd be like, wait, somebody just port scan my machine. Anyway, this is always funny. All right, so they can totally be detected. And so if you go start port scanning a whole bunch of machines, it might look like you're doing some kind of malicious activity. And you could take this whole thing one step further if you're on a server. If you're like, all right, people with port scanners are usually up to no good. So if any IP address is found running a port scan on my server, we'll just go ahead and block any connections from an IP address of the firewall leading to the server. Yeah, I mean, you could rig all that stuff up. It might be a little bit overzealous, but you can do it. Okay, that's port scanning. Now you know. Okay. I had one more thing that popped in my head that I had to explain today, and then it just left, and it hasn't come back yet. And I didn't write it down in my notes either. So, I think it was relating to, the project description, that's it. We're gonna look at the project description. All right. I'm not an orderly lecture person. Part of the problem is I'm a little bit of an unusual person. I've always had trouble paying attention to lectures. They put me to sleep, even ones, especially ones I'm supposed to listen to. So, like a PowerPoint. I mean, if I come into the room and there's PowerPoint, I'm always like, oh brother, it's nap time and I need to know what's on that PowerPoint. So I've always kind of avoided it like the plague. It is the major way that lectures are done. And I'm assuming there's a reason for that. It's not just because people absolutely love slide transitions. All right, 6.35 is for the CS-435 web. All right, all right. The only thing I really want to revise on this thing is actually the due date, and I think I might have already revised it and just not posted this whole thing. So the usual way I set this one up to be due, we have the client due about then, like the beginning of March. It'll be something like that, and it'll be about class time. And usually what I like to do for the clients is set up some map, and then we go on a quick raid with our clients, and hopefully our client doesn't fail you. Now, this turns out to be a little bit of a problem if you show up and you're like, oh, my client's not done. Now I'm going to go on a raid with LC. I guess you could use LurkWolf. Before we had LurkWolf, if you didn't have a client, you ended up going with LC, and that was really painful. All right, LC isn't supposed to be easy to use. It's supposed to help you debug stuff. All right, that's that. And the server actually has kind of a progressive turn-in. The basic tests, I have my lurk test script, and so it should pass that one by April 15th. And usually there's some points associated with that one, so everybody gets it done by then. And that way you have a little bit of room to think about what you want your server to be like in a literary sense, or fix bugs that pertain to the advanced tests only, not the basic tests, or things like that, before we get to the actual presentation week. So yeah, about that week. Sometimes the presentations take a long time. The presentation sometimes turns into a debugging session where everybody is scrambling to fix their servers, because you know, we usually come in and it's like, oh yeah, who's ready? And somebody's like, oh, I'm ready. Everybody log into my server, and then it crashes. Then they're like, oh, hang on, I think I know what the problem is. And then we're like, okay, we'll log into somebody else's server. Will you figure out the problem? So we log into somebody else's server, and then it crashes. And then they're like, oh, you get that. So sometimes these things take a little while to finish testing. All right, and then you turn in a final version later with allows for the bugs fixed, and I grade that in a conventional manner, or log into it. A lot of times I'm like, oh yeah, just run it somewhere, and I'll run lurk test with like 100 bots, and we can see that your server is perfect now. All right. These they should be unique. And create your own. Don't share code for it. I think this assignment's a little bit less tempting to do that on than some others, because there really aren't any other lurk servers on the internet that weren't written by somebody in this class. I wouldn't be too surprised if somebody or other had taken a class that is sitting around in their GitHub repository so that they could show potential employers or something. The ones from the class are pretty recognizable. All right, so it should be unique, not share any source code, but anybody's client should talk to any server. All right, mentioned the other stuff. For this, the server must be able to run on a software. What I should have probably said there, maybe I'll revise it before I post this thing. I'll try and post it like 15 minutes after class. It should be able to run on a server. Like, everybody should be able to access it, whether they're in this room or whether they're in some other city, like Portland. It should be a server that you can get to. All right. It causes a problem even in this room. If you bring in one and you're like, hey, it runs on my laptop. Because we can't get to the wireless easily from the wired side. So anybody sitting at one of these computers isn't going to be able to log into your laptop server, unless you put it on the wired network. And then nobody on the laptop is going to be able to connect to it. So yeah, globally accessible. That way, if half the classes decided to go on vacation in, say, in Wuhan, China, maybe the hotels will be like super cheap in a couple of months there. All right. That's that one. All right. Since you're looking at this, if you're like, yeah, I've been thinking about UI toolkits. I really want to get more practice writing Microsoft.NET UI stuff in C#. Yeah, go for it. Perfectly fine. But you'll have to show me your client. I'm not going to be able to run it. That's okay. All right. Yes, if the user is required. All right. So if the user is required to type, incoming information must not disturb the typing. So like with LurkWolf, the user is required to type. That's the main way they operate with LurkWolf. With Jesse's client, I should see if he wants to come in and just show everybody his client on Monday. Show it off. You put a lot of effort into it. You probably like that. Yeah. All right. I don't know if he's busy right now though. Anyway, if he wants to come demonstrate it next week, we'll see if he wants to. But his, you don't type as much. So, can't disturb the typing. So this pretty much bans any kind of command line client that doesn't use curses or something like curses to sort everything out. All right. Client must support the full lurk protocol. So the full lurk protocol does have a few little options on the server side. You don't have to support extensions. That's extensions. That's not part of the regular protocol. We haven't had extensions before. I should probably clarify that on here. All right. So then with the server, you're going to have to support the full lurk protocol. That said, there's a few things here on this server where they can be disallowed. The PvP is mentioned right there. And in the protocol, these things are identified. With the PvP, it mentions that not all servers support it. If a client sends you a PvP message, your server shouldn't crash. It should just respond with the appropriate error that you can't fight each other on this server. Everybody likes each other here. All right. Yes, must support multiple clients. Yeah, for sure. And I put a couple of minimal requirements on the map and entities. It's a lot of the time the server map's much bigger than that. I'm not sure my map quite qualifies on this, I just make up enough map. All right, it's got to be interesting on server exploration day, and then it's got to be persistent. So you can clean up bodies and things later, but the server should maintain a state as it goes. That doesn't just go away right away. Is it?
So if they leave, they should be out of the map, but if they die, their body needs to stay there.
Well, you can decide what you want to do if they leave. My server leaves them laying around in the map. The available for looting, if I remember right. But you can decide. I mean, if on a server you want to say, you know, when you leave, you like go back to the camp and stay there and put all your stuff in the locker. Yeah, that's fine. You can do that. And then it encourages people to actually leave instead of just disconnecting. All right. Yeah, that's that one. All right. Server grade items. I usually put this together in a few different items. The client's kind of all one thing, but the server, you get points for whether it passes the basic tests and meets these things and whatnot and works. These 60 points together basically mean we all logged into your server and had fun playing on it. I mean, if that's true, you know, you'd be good. Yeah, can't crash or otherwise fail to perform. A lot of times, if you have like a simple bug right away and you can fix it, you know, we say that's fine. Basically, by the end of server testing, we have to have had fun. And then you get last 10 points for fixing the last few bugs out of that. All right. So usually that ends up with the servers actually basically graded at the end of the semester. And so with this class, you usually know where your grade is going into the final. Not always true with all of my classes, because a lot of times my classes will have a large assignment that's due around finals week, and then you've got an awful lot of outstanding grade at that point. All right. So hopefully that makes sense. Everybody's excited about it. All right. Okay. So that's probably most of what I've got now. So then we're going to kind of switch gears in the class coming up next, and we'll switch to layers. Right there. I guess it's just on the slow list. I need to fix that one. All right, this is network class. There shouldn't be any dead links. All right, so this has been a week 10 one. Oh, no class Monday. Or we don't have class Monday. We never have class Monday.
No, we do.
We do?
Today's
Okay.
Wednesday.
This Monday.
Right, all right. Sorry, I was thinking it was a Thursday today, but it's not a Thursday today. I have a class in here that's Monday, Thursday, and one that's Tuesday. Or no, whatever. You guys understand. Maybe. It doesn't matter. I don't know how I ever got this job. I'm actually not very good at explaining things. All right, so next we're going to move on to the physical layer on Monday. So the physical, you know, this is like hardware and whatnot. So we'll go over basic cable types. Casey has gone in and organized all of this stuff, which is kind of nice. It looks like I'll need to bring in a coaxial cable and maybe a fiber optic cable to have the major examples. All right, but when we start doing this part, it's more going to be on how networks work. And so we won't really talk about network programming very much for a while. Eventually we'll talk about network programming again there. And I might try and stick in some kind of basic review of how servers work sometime around the time when you start writing a server, if that's useful. Or maybe just after you've started writing the server and then everybody's got lots of good questions. Or we can do a question and answer where if you have a good question, you know, you mention it when we review how servers work. We'll probably do something like that. I'm not going to take the network programming and completely leave it alone for the entire rest of the time, but it'll be de-emphasized. All right, once we get to the layers, I'm hoping for about a week on each, but usually some of them go a little bit long, especially the physical layer. And especially since I don't think I thought very much about that no class Monday when I put the physical layer for its week. But that'll be okay, because if we get to the application layer in a little bit short time, we're writing alert protocol in the application layer. Usually for application layer week, I pick a couple of popular application layer protocols to talk about, like HTTP or something, like, you know, let's write a web server. This will be the web server that, you know, takes every request that you give it and gives you back the same thing for some reason, or, you know, you request a web page and it adds it to the log, and so then all it always goes back is just a log of what everybody's requested. Anyway, something like that. I don't know. There's a whole bunch of protocols at the application layer. As you get to, well, it's actually, I guess, kind of funny the way things work out. There's an awful lot of data link layer protocols, but when we're at the network and transport layer, I mean, mostly we just all use IP version 4 and either TCP or UDP. Typical messages have kind of the same ones. There's management protocols in there. So if you look at the Wikipedia entry, like list of protocols at layer 3 or something like that, there is a significant list. But most of them aren't ones where when you send a packet from your application, like Lurk, that protocol ends up being involved directly. There are a lot of protocols that manage routers and switches and workings of things. Anyway, I guess we could write something for that on there. But application is where you see the biggest one. Maybe it should what I mean. All right. All right, there's a particular graph that I want. Hey, there it is, first try. All right, so down here, the link layer, you see quite a few different entries in your list here, but then you actually notice there's like less entries in these until you get to the application layer. And it does have the more, so in a way this isn't totally representative. But, you know, if you, all right, it's a big list. Somebody here has come up with ones they think are really significant and then put them in here, and they've got more examples of the application layer than anywhere else. And that is kind of how it comes down. There's more protocols up there than about anywhere else. All right, so when we get to application layer, we'll pick a couple. Oh, SSH might be interesting. I never covered SSH in this class before. Oh, we never talked at all about how it works. We used to have a security class, and the security class, I haven't been teaching it lately, just because I keep teaching stuff like game engine design instead. Game engine design is very popular, although the security class is occasionally on demand too. I should probably redo it one of these days. I suppose we could actually talk about network security for a week, since most of you probably haven't had that class, and it might be interesting. Thumbs up on it. All right. I'll think about sticking that in there, because I've also got those demo weeks at the end where I think of something. We could take a week and talk about encryption, or we could make one of the demos be an encrypted program that sends secure messages or something. I've done that in security class before. Haven't done it here. All right, cool. Well, if you really, okay, you thought the security sounded interesting. Okay. All right. Well, that might be more than is usually interested in my demos, or like we make a DNS server that just resolves every last thing to, you know, some particular address that we think could be fun. All right, well, I'm pretty well out of time, so I'll see you all next week on Wednesday. This Wednesday.